In this video, we're going to be talking about the trigonometric form of a complex number. So we've learned how to add, subtract, multiply, and divide complex numbers. But to work effectively with powers and roots of complex numbers, it's really quite helpful to write complex numbers in trigonometric form. So let's talk about what exactly trigonometric form of a complex number is and how do we get there. So let's consider the point a plus bi. So right there. So let's say that I graph it and it's over here. So we have our a plus bi point right there. And so this is going to represent our a, and this will represent our b. And then we're going to have this right here represent our r, and we're looking at a right angle right there. Now, by letting theta be an angle from the positive real axis, so we're measuring it counterclockwise to the line segment, it allows us to be able to write that let's do that with the blue so we can kind of see it transfer. It allows us to say that a equals r times the cosine of theta, and it allows us to say that b equals r times the sine of theta, where r is going to be the square root of our a squared plus b squared. It's just that standard Pythagorean theorem. And then our tangent of theta is going to be our b over our a. So likewise, we would be able to also say, right, that then the sine of theta would be our a over our r, and the cosine of our theta would be our b over our r. So we could say that as well. So let's get back to our trigonometric form of our complex numbers. So here, what we're able to do is we have our a plus bi, and we know what a and b is. So if we were to plug those in, we would be able to say that z equals r times the cosine of theta plus our b, which is r times the sine of theta I. So what do these both have in common? Well, they both have an r in common, so we can pull that r out. When we pull that r out, that leaves us with this right here, which is our trigonometric form of our complex number. In this particular instance, we see that r is called the modulus of z, and that theta is called our argument of z. Now, when we were talking about vectors, we said that the r was our magnitude. But now, because we're talking about complex numbers, the r is our modulus. Okay, the r is our modulus. Sometimes the trig form is also referred to as the polar form. So if you hear that, just be aware that those mean the same thing. Now, because there are infinitely many choices for theta, the trigonometric form of a complex number is not unique. So normally theta is going to be restricted to the interval between 0 and 2 pi. Although on occasion it is convenient to use that theta has to be less than 0. So let's go ahead and let's move on to an example. In this example, we're going to write the complex number z equals negative 3i in trigonometric form. So we're going to start off by graphing it. So we're going to have 0, negative 3. So we'll graph our point. Give our 0, negative 3 right there. And so in this particular instance, it's actually quite easy to see what our theta should be, right? If we're starting from here, we're going clockwise to our point. If we use our unit circle, we see that this is our 3 pi over 2. Now remember, the reason that we need our theta is because z equals r times the cosine of theta plus I times the sine of theta. So we need that theta. So we're able to say that theta equals 3 pi over 2. Now, in order to find our r value, we would normally need to find the square root of a squared plus b squared. But in this particular case, we can find the distance from the origin to our point pretty simply because we're on an axis. So we're kind of able to count that 1, 2, 3. So here we see that our r value is a 3. So from here, we're going to go ahead and plug in what we know, which gives us that z equals 3 times the cosine of 3 pi over 2 plus I times the sine of 3 pi over 2, and we're done. This is our trigonometric form of z equals negative 3i. Well, if you have to be able to put it into trigonometric form, you also need to be able to write it when you have to use more than just the axes to count your r values. So let's take an example there. Look at that. So here we're going to be writing the complex number z equals negative 2 minus 2 square root of 3i in trigonometric form. So the first thing we're going to do is we're going to graph that. So we're graphing negative 2, comma negative 2 radical 3. So I'm going to go over to negative 2, and then I'm going to go down to about kind of in between the negative 3 and negative 4 is about where negative 2 radical 3 is going to be. And so we have our point from the origin to our point, and we need to know our theta. And we also need to know our r value. And so let's start by finding the absolute value of our r value, or of our z value rather, which is finding our r. So we're going to have the square root of our a squared plus our b squared. So we're going to plug those in. So we'll have our negative 2, then negative 2 radical 3. And if we plug that into our graphing calculator, or just into our calculator, we should get an r value of 4. So now we have an r value. But we also need to know our theta. And this one's not as easy as just counting on the axis. So in order to use this, to find that, we're going to use tangent of theta. So remember the tangent of theta is b over a. So we're going to go ahead and set this up. We're going to take our b, so negative 2 radical 3 over our a, which is negative 2. That's going to allow us to cancel out our negative 2's, which is going to leave us with a tangent of theta equals the square root of 3. Using our unit circle, we know that theta is going to equal pi over 3. But our calculator really only gives us an answer that's in one of these two quadrants here, the first and the fourth, but we're in the third quadrant, so we need to add a pi period to this, which is going to then give us that our theta equals 4 pi over 3. And so now we're ready to write our z in trigonometric form. So we'll have z equals r times the cosine of theta plus I times the sine of theta, and we're finished. That is our solution in trigonometric form.